Hi, this is your host Apin Bhartiya and welcome to Tier 4 Let's Talk About AI. Today we have two guests from Skymel, Sushant Tripathy, co-founder and CTO, and Neetu Pathak, co-founder and CEO. Sushant, Neetu, it's great to have you both on the show.
Thanks, Swapnil, for having me on the show. It's an honor.
It's my honor, it's my pleasure to host you folks here today. And since this is the first time I'm talking to you, and since you're also co-founder of the company, I would love to know a bit about the company, when you created it, why you created it, what problem you saw that is still there in 2024 that you needed to create the company. So tell us about the story, the history of the company.
First, let's begin with when we created this company. So we recently launched out of stealth, end of May, but we were funded by Unusual Ventures end of last year, 2023. So that's officially when we were founded. A couple of months before that, we incorporated, of course. And so Skymel is the company to introduce onto the AI industry, the first of its kind, adaptive inferencing technology that splits dynamically in real time AI inference between two endpoints, the end user device and cloud servers. In doing so, we offload up to 30 to 40% of the AI inference tasks onto the end user device, reducing the compute capacity required by the cloud servers and also the VRAM required by the cloud servers. This essentially leads to a 60% reduction in the cloud server costs. Now, how does that reduction happen? We'll go into depth of that in a little bit. But what this enables a lot of enterprises to do is use older generation GPUs to deploy latest gen, even Gen AI models. And if you know, currently we are in an AI gold rush. So GPUs, like they say, when there's a gold rush, sell shovels, right? And GPUs are the shovels. So the latest generation of GPUs are very scarce. The supply cannot really keep up with the demand, and that has made a lot of the AI projects unaffordable and unscalable. So what we are trying to do is we are trying to move those currently existing state-of-the-art systems to older generation GPUs, which are a bit more available and hence cheaper.
Whose problem are you trying to fix here?
So primarily it's the enterprises that deploy AI applications. So they want a couple of things. They want a superior scalability of their applications without increasing their backend costs too much. And B, one point they cannot absolutely compromise on is the user experience. So users of AI-enabled applications, be it some search application, some recommendation engine, they don't usually know what goes on behind the scenes, but they do have a high expectation of these AI-enabled applications. They want immediate responses, real-time responses if possible, and they don't want those applications to slow down their PC's performance, consume their battery and stuff like that. So the user experience and the cost factor, those are the two challenges we are solving at the same time for enterprises that deploy AI-enabled applications.
When I was like, whose problem are you trying to solve? I was also kind of curious about, are you talking, when you look at Skymel, are we talking about enterprise customers of cloud providers or cloud providers or people who are offering GPUs to users they can also leverage? So I just want to understand your user base. Who is the target audience there?
Our primary target audience is anyone who makes an end user AI enabled application, something that is user facing. But like you mentioned, the cloud users, cloud service providers could also be an endpoint that we have not thought about, since they would be getting to distribute their older GPUs to AI application providing enterprises a lot more. But our primary goal is now just set on the AI application providing enterprises.
You also talked about leveraging older GPUs, and you also talk about cost, optimization or reduction. And these are becoming a pain point. Folks do want to leverage, but GPUs are expensive. It's hard to find GPUs as well. And of course, cost. We have not started talking about the cost which is related to Gen AI. People are just jumping on a bandwagon, and then of course, after a year they'll realize it. What are some of the biggest pain points that you saw in the industry? And I'm not talking about companies who are just jumping on the bandwagon, just the way Kubernetes, everybody, hey, we have to use Kubernetes no matter what we are doing. Same thing with Gen AI. Where realistically, where you say, hey, these folks, they actually do need, I mean, everybody needs Gen AI. I need Gen AI just to help with the videos, but there are industries, they really need it. It's critical for them. From their perspective, the real use cases, what are some of the biggest pain points you're seeing? Resources, availability of talent, cost, availability of hardware, or others?
So it's a combination of all of them. I would say in that mix, availability of talent is not as much an issue as is the cost of the talent. So let's add that onto the costs. So if you are deploying a Gen AI specific application, you do need some folks that have background in Gen AI. Unless there's a platform that's willing to abstract all those complexities away from you and just give you a few click deployment. And there are platforms that are solving those issues. I think like a couple of platforms like Hugging Face come to mind. But the second issue, which is still occurring, is the cost and scalability. Very often, if you're just relying on cloud servers with Gen AI applications, you have to scale horizontally, as in add more GPU-enabled servers. And that is something that still happens as we scale. But with Skymel, you can scale horizontally using older generation GPUs, which will be a lot cheaper. And that's where essentially the cost savings come in. And yeah, so that's pretty much what I've been seeing. And in certain LLM-enabled applications, for example, the response latency is very critical. So the time to first token, that has to be pretty low, as low as possible, in order to not lose user engagement.
What does your offering look like? What does your product, what does your services look like? And what is it? Is it SaaS? Is it something you install on a server?
Our offering is essentially a library that abstracts away a few of the complexity of model deployment, if you are willing to let us handle the model deployment. And primarily, we focus on inference deployment. What that means is that, say you give us your model, this is the model you want to run. Our library then takes that model, individual models, and then chops them up into two pieces, several chops, really. So every chop is a stub model that runs on the user's device and a full-length remaining stub model that runs on the cloud server. And then our library figures out in real time, okay, where do we run this inference model? For example, if you have a MacBook Pro, you have probably a lot more idle compute on your device than a lot of other smaller laptops. So in that case, maybe you can run 30 to 40% of the inference model on your device and finish the remaining 60% on cloud server. Say you have an Alienware Pro, then you can probably run a lot of the models entirely on your device. But say on the opposite spectrum, you have a KaiOS Android phone. You can barely run anything. So in that case, so what our library does, it dynamically figures out how much idle compute capacity you have left over, and if we can run some portion of the model within that capacity. If not, it falls back to the cloud server. And if yes, it runs a portion of the model, and the remaining computation is then done on the cloud server. Now, what happens in this scenario? So usually for single pass models, you reduce the response latency because a lot of the data processing is happening on your device itself. And for certain other models, and at the same time, you also reduce the compute requirement and VRAM requirement of the backend server, also the peak GPU requirements. Usually there's an over provisioning of 30% to adjust to the peak population in the backend. But in this situation, you can decrease that 30% to say 20%. And you can fill that up with older generation GPUs, which are not as compute capable, but they're cheaper. So that's where the price reduction comes in. And just to demonstrate that point, we have this live demo running. What I'm going to show you right now is an image tagger. So it essentially takes an image as an input and produces confidence scores in 2640 tags as an output. Now we have three columns underneath, as you can see. One is called cloud, the other is called device cloud, and the last one is called device. So it runs the same image through three different modalities. The first one, it sends the image directly to the cloud server. 100% of the processing happens on the cloud server. The second modality, device cloud, it's Skymel's library NeuroSplit splits the model into two pieces. in which 30% of the model runs on the device. The activations are then sent to the cloud server, where the remaining 70% of the compute happens. And the last version is a quantized model that can run on your devices, downloaded onto the device, and the entire quantized model just runs within this user session. So I'll be doing one run in real time, and then I will go to a different tab where I've run a lot of them multiple times. So like I said, this is an image tagger. It produces these tagged results. You can change the confidence threshold to see more or less tags. Only the tags exceeding this confidence score are populated. And here we have some metrics like the latency metrics. So let's go to a full run where I have run a lot more, and then we can have a better sense of what the average latency looks like. So here, what I've shown you after running 7 or 8 images is the average device latency is the lowest in this case. And because this is an Alienware laptop, I can run this model entirely here. You may not be able to. So even in our device cloud split, what I would like to mention is if you look at the average response latency between just the cloud server and the device cloud split, it's very comparable, which means that we are not degrading user experience. And now that we have offloaded 30 to 40% onto the laptop, we can save that 30 to 40% computation requirement in the back end. And this graph just basically shows how the latencies vary over images. So again, goes to prove that we don't actually lose a lot of response time in terms of device cloud splits. And in doing so, we're able to save that's 60 to that 30 to 40% compute requirement on the backend, and downgrade the backend GPUs to an older generation GPU, thus savings. So if you look at just the price difference between an A100 and an RTX A6000, you'll find that those are significantly different, up to 60% sometimes.
And if I'm not wrong, the foundation of the work that you folks are doing is NeuroSplit. Is that correct?
Yeah.
If you can also share the origin story, so that would be great as well.
NeuroSplit is our core offering. It's a library that continuously detects how much idle compute is available on end user device. Now, if the compute is enough, we run the entire model. So we download a quantized version on the end user device and we run the inference on the device itself. Now, if the compute is not at all enough, then we send the inference request back to the cloud, get the response, and serve it. Now, if you have some compute available on the end user device, but not enough to run the entire inference, then NeuroSplit splits a single model into two parts. The first part is quantized and it runs on the end user device. An intermediate output then is sent back to the cloud. It finishes processing and sends the response back. And this whole thing is dynamic. So every few minutes, in the background, we are figuring out how much idle compute is available. And based on how much idle compute is available, only that computation is used for the inference. Now, one important thing that is important for the developers who are watching this, we allow you to set up 4 different priorities while using NeuroSplit. You tell us what is more important to you. Is it latency more important? Is cost more important? Is accuracy more important? Or is privacy more important? And based on the priority that is set up in the library, NeuroSplit decides where to run the inference and how much to run on the end user device.
Now, when we look at NeuroSplit, the whole AI inference and especially cost reduction, is there any limitations? How many users are there, local versus cloud? And also, most folks these days, we talk about multi-cloud, hybrid cloud. Things are running on the edge as well. How does this fit in that scenario?
This would be an example of hybrid cloud technology. And regarding how does it deal with multiple users, so one of the primary advantages you have with NeuroSplit is that every new user brings a new user device, end user device, right? So that end user device may have some idle compute capacity. So if there is absolutely no idle compute capacity, which usually doesn't happen, then the offering would be similar to any cloud backend, which is currently the cloud backend you are using. So we don't entirely replace the cloud backend. We sit as a orchestration layer between your own cloud backend. You don't have to move from your current cloud backend at all. It's a very low code, low friction integration with us. You just have to give us the model and we'll do the rest for you. And then we sit between your end user and your cloud backend, and we decide in real time where to run how much of the model. Uh, Worst case scenario, there'll be no change to your billing whatsoever. And average case scenario, you will get a 60% reduction. So that's our offering.
We started recently talk, I mean, we almost forgot about developers. We started talking DevOps, DevSecOps, SREs, but now we have started talking a lot about developer experience. Folks has also started talking, even Kelsey Hightower, who once used to say that Google Cloud was his local machine, or dev environment. He is also starting to say, that things should move closer to user. That's where I want to run my workload. What kind of user or developer experience does NeuroSplit or Skymel offer?
The developer experience with us is very low touch. So I'm sure you're familiar with Hugging Face endpoints. So essentially, you just point and click which model you want. We have a bunch of open source models readily available. In addition to that, if you want any closed source, your own models, you just upload it in our dashboard and we will split it for you. That's our beta offering. And then we'll give you an endpoint URL. You just have to use our library and give that endpoint URL in that library. Hey, wherever you are calling your own model, just use that endpoint. And then we figure out the rest in real time. So that's the developer experience. So one thing I would like to point out, previously, before Skymel, a lot of the times developers had to ideate and decide on one of two pathways. Are they going to be completely on device, or they are going to be completely on cloud? With us, they have a fluid choice. They can switch it on to on device or on cloud at any time within the life cycle of the program they're developing. And the second thing is the user experience. So it's kind of opaque to the user what's happening. What we're doing essentially for the user is we're standardizing the user experience. No matter which device you're on, you'll more or less get the same user experience. So we do have operating points like response latencies or performance metrics like accuracy or whatever. So you can select a couple of operating points and we'll optimize. Our library will take that into consideration to optimize for it. So you can either optimize for latency, for performance metrics, or costs. So that's also a choice we offer the developers.
I mean, this space is kind of getting crowded. You folks are new players, new entry in the space. Why would someone choose NeuroSplit as compared to other solutions which are available? And of course, you may not want to talk about that. Who would you consider your competitor?
So our competitors list is a bit wide in the sense a lot of the applications current, or a lot of the companies currently available are offering similar terms, but they're not exactly doing what we are doing. For example, there is Grok, who is offering a very fast cloud inference engine for LLMs and stuff. And then there is Bastin. There is a lot of these folks are offering cloud optimization on cloud side and reducing your cost. The funny thing about us is that you can choose anyone as our backend. We'll still get you cost reductions on top of that backend, because we are offloading whatever. So a lot of these folks are focusing on, hey, I'll optimize your code to run better on GPU with lower RAM requirements, lower compute requirements. Good for us. We don't care about who your backend is. We are just the orchestration layer. So if you're spending X on your backend, we want to make it 0.6x. That's our offering.
You folks came out of stealth recently. Talk a bit about what is your plan for funding? What is your plan for growth? What kind of things we can expect from the company in 2024?
We have, like Sushant said, we have a bunch of enterprises that are interested. And we do really well when we are talking to very technical folks like the CTO of the companies or VP of AI, because like Sushant said, people didn't believe that the inference can be split. Like, yes, you can run a very small model on the device and have a bigger model on the cloud, but chopping a single model into two and then running a part of it on the device and the rest on the cloud, this was something that no one thought could be done. So this is the reason like a lot of enterprises are interested. So for that, we do want to raise a seed round of which looks like 7 million at the moment. And we plan to hire 10 engineers by end of it, which will also include 2 professional services people, mostly because all our clients are enterprise and they need a little bit of white glove treatment. We want to make sure that we don't miss out on those customers just because we cannot keep up with the demands of them.
What kind of use cases users you were expecting to get?
They depend from either a cost perspective or latency perspective. So to give you an example, I'll take two examples. These are simple. I'm not talking about Gen AI, just let's go the traditional route. So if you're a recommendation engine, right? A lot of recommendation engines or companies, they're still doing batch recommendation. There are two reasons for this. One, sometimes it's too complex to run real-time recommendation. Now, even if you throw a lot of resources at it, like the engineering resources, and you create a very great real-time recommendation engine, the cost starts eating up into your revenue. So it's not substantial. So batch, even in 2024, many companies are running batch recommendation. So when we come into play, you can run, kind of mimic this real-time recommendation system because you're using users' device to run the computation in real time as they're interacting with your video application, but you're not paying the price for it. The second would be, okay, think about all the social media applications, right? And one of the biggest challenges is NSFW content. They don't want anything bad to end up on their server. So if you're running everything on the device itself and you gray out the upload button when something bad is going to get uploaded, instead of sending it to your cloud server and then putting a manual review team to review it, that is also a saving. So at the end of the day, I think where we stand out is not only the cost, it's the best user experience that you can provide. It's the, if you have heard the term hyper-personalization, I know it's thrown out a lot, but you cannot provide hyper-personalization with all the changing laws that are coming in, where you cannot touch user data or you cannot store it, or you might be able to run something today, but 6 months down the line, you cannot use the data. In those scenarios, we become more and more, we become the right choice for the companies. So that's why we always stick to two things. We reduce the inference cost and we give you the highest quality end user experience that makes sure the engagement goes up.
Sushant, Neetu, thank you so much for taking time out and talk about the company, for technology. And so this is the very early days, but I do see a lot of stories are coming out of the company. So I'd love to chat with you folks again, but I really appreciate your time today. Thank you.